Okay, lesson 2-4, parallel and perpendicular lines. Guys, this is the last lesson in chapter 2. So by the end of the week, we'll be talking about a test. I mean, we'll be taking a test by Friday. Okay, so how many of you are gone tomorrow for the Leadworthy trip, by the way? Just like a couple of you?
I'm not.
Okay, so I'll be gone tomorrow too. So there won't be like new stuff. There might be like a new review of some kind, getting us starting to get us ready for the test. Okay, so objectives: write equations to represent lines that are parallel or perpendicular to a given line. Graph lines to show an understanding of the relationship between the slopes of parallel and perpendicular lines, and solve real-world problems that involve parallel and perpendicular lines. Think of those objectives while we go through the examples in the lesson today. So here is, it's just going to be procedural stuff. We should know how to use all the equations that we have at this point. We've got slope-intercept form, we've got point-slope form, we've got standard form. Using any of those given forms, we can then find the slope of the line, we can find a point that's on the line, all of that stuff. And then if they give us information regarding a new line, then we can write equations for that new line as well. Okay, so starts off with write an equation of a line parallel to a given line. So the equation of the line in slope-intercept form that passes through the point. So our new line is going to go through this point, and it's going to be parallel to this line. So that tells us that this line does not go through the point 89, right? So we want to write an equation for a new line that is through point 89 that is parallel to that line. So parallel lines are lines in the same plane that never intersect. Non-vertical lines that are parallel have the same slope but different y-intercepts. Those words should all mean something to you guys, all right? You should understand everything that said. So especially this last sentence, non-vertical lines. Non-vertical lines are the exception. We still have parallel non-vertical lines, but they don't have a slope, right? We don't talk about the slope of vertical lines are undefined. So non-vertical lines that are parallel have the same slope, but different y-intercept. Also, vertical lines don't have y-intercepts. Think you understand that? Because if you have a graph and you have a vertical line, it's parallel to the y-axis. It never touches the y-axis. Then it still doesn't have a y-intercept. It is the y-axis because it doesn't have one point where it contacts the y-axis. Okay, so let's talk about our steps here. What is the procedure for writing an equation that goes through this point but is parallel to this line? So we know the slope of this line, right? Because we've got a slope-intercept equation. So what's the slope? 3/4. So I want a line that has a slope of 3/4 and goes through 8, 9. What form of an equation do I know that can use the slope and a point slope form, right? So I've got an equation that is just y minus y1 equals m times x minus x1. All I got to do is plug numbers in. So it's going to be y minus 9 equals 3/4 times
x
minus
8.
8. Okay? So now, have I done what it asks? What form do we want the equation to be in? Slope-intercept form. So what do I need to do?
You need to distribute and stuff.
I need to distribute this, and I need to get y by itself. Slope-intercept form is like this one, where y is by itself. So I can do this in 2 steps. My first step is distribute. My second step will be to add 9 to both sides. So y minus 9 equals 3/4 x minus, what's 3/4 of 8? Minus 6. Okay?
And then now we need to do 6 plus 9.
Add 9 to both sides. So y equals 3/4 x plus 3. Negative 6 plus 9 is positive 3.
I knew that.
Okay, so that answered the question. Okay? That wasn't so bad. That was pretty simple. All right, let's do the next one. So write the equation of the line in slope-intercept form for the line that passes through the point negative 3 comma 5 and is parallel to negative y equals negative 2/3 x. Same process. We know the slope. We know a point. So yet let's use point slope form. Y minus 5 equals
negative 2/3 x plus 3.
plus 3. All right, since it's a negative 3, we do that. Okay, 2 steps. Distribute, then get y by itself. So y minus 5 equals negative 2, oops, that was supposed to be a 2. Negative 2/3 x minus 2. Add 5 to both sides. Y equals negative 2/3 x plus 3. Not too bad so far. All right. What's next?
The same thing. Oh, no, it's
Understand the slopes of perpendicular lines. How can you create 2 perpendicular lines? Perpendicular lines, you know what they are. They form right angles, right? So the slopes of perpendicular lines, this is the key, this is the thing right here, opposite reciprocals.
reciprocal.
So a reciprocal, when you think of reciprocal, you think of a fraction, right? And you flip that number over. So that's the reciprocal. So what does opposite mean?
Flip.
Opposite.
So you flip, so then you don't.
If it's positive, it becomes negative. If it's negative, it becomes positive. So that's the opposite part. It's an opposite sign. Because think about it, if I have a line that's like this, that's a positive slope, and I want to make a line parallel to it, so it's got to form a right angle. You know, it's got to go that way, so that line's going to have a negative slope.
That's not parallel.
It's as close as I can do freehand.
No,
All right.
you said parallel.
Did I say? Oh, perpendicular is what we're doing. I didn't mean to say parallel. I meant to say perpendicular. That's what we're doing on this slide, perpendicular. All right. So, okay. So, what is the equation of the line that passes through point 17 and is perpendicular to the graph of y equals negative 1/4 x plus 11? So here's the slope of my given line. What is the slope of my parallel or perpendicular line going to be? Now you won't be able to say the right word.
Or 4, negative 4.
So if I want, if this is my given slope, and this is the symbol for a parallel line, it's an upside down T, or I can't say the word perpendicular. This is the symbol for a perpendicular line, it's an upside down T. So I want the perpendicular slope. Okay, perpendicular slope is positive 4/1, which would just be a positive 4 slope. Okay, so that's the perpendicular line. And I want it to go through this point. So y minus 7 equals 4 times x minus 1. And all it says is the equation of the line. Have we written an equation of the line? Are there different forms of that equation that we could write? It doesn't specify slope-intercept form. It just says an equation. So we're done. I mean, this one's finished. Does that work?
I solved it, but
Well, you can make it slope-intercept if you want, and that's fine. But it doesn't say what is the slope-intercept equation. We've written an equation of the line, and from there we can go anywhere. So I'm okay with that. All right. The equation line that passes through 4, 5 and is perpendicular to the graph of y equals 2x minus 3. So perpendicular to a slope of 2 is what?
Negative 1/2.
Negative 1/2. So I want to write with a slope of negative 1/2. So that's gonna be y minus 5 equals
-2.
negative
One
1/2
half.
times
X minus 4.
x minus 4.
Okay, where did 1/2 come from?
It's opposite reciprocal of 2.
So you flip the positive to negative and also flip it. Flip
Oh,
the
so even if
fraction.
it's not a fraction, you still flip
So
it.
yes, so my original slope is positive 2, that's 2 over 1, so the perpendicular slope would be negative 1 over 2.
Okay, I thought.
All right?
I get this now. So
Yes.
perpendicular would just be if it's positive, we make it negative. If it's negative, we make it positive. And you flip the top to be the bottom.
Yep, you flip the number over. Top becomes bottom, bottom becomes top.
Mr. Frisch, is this the easiest lesson we'll have all year?
Well, let's see if it continues that way.
I hope so.
Okay.
Don't say it like that.
I don't like that. That scares me.
Are the graphs of the equations 3y equals negative 4x plus 6 and y equals negative 3/4x minus 5 parallel, perpendicular, or neither?
Why did you have to say?
So, all we got to do is find the slopes of both lines. One of them already has the slope in it. Okay?
They both are good.
This one, we can find the slope in one move of this one, right? What's our one move we need to do?
You need to divide it all by 3.
Divide by 3 to get y by itself. So if we divide by 3, then I would have y equals negative 4/3 x plus 2.
Nope.
So parallel, perpendicular, or neither?
Fine.
Neither, okay? Because negative 4/3 is not the same as negative 3/4, so they're not parallel. And they're not opposite reciprocals. They're reciprocals, but they're not opposite reciprocals. So they're both going to be going negative, so they can't both be, perpendicular. So this one is neither. Okay? So that's not too bad. I mean, you gotta kind of think about both lines. Are the graphs of the equations parallel, perpendicular, or neither? So let's do A first. So what is my slope of the first one? 2. What's the slope of the second one? 1/2.
They're not the same.
So that one would be neither. And then negative 5. And then we've got to solve this one. So subtract 25x. So that would be 5y equals negative 25x plus 1. Divide by 5. So that would be y equals negative 5 over 1 x plus 1/5.
Yeah, that's.
It's
Oh,
still
then that would be
negative.
parallel.
It's
Parallel. We've got a negative 5 here and negative 5 over 1. I mean, I wrote it funny so I could trip you up good. But what's 25 divided by 5? 5. So it's negative 5. So this really is y equals negative 5x plus 1/5. Okay, so they have, boy, they're parallel and they're really close together. What's the y-intercept of this first line? Y equals negative 5x. What's the y-intercept?
0.
0. There's no y-intercept listed, so it's 0. What's the y-intercept here? 1/5. So they're really close together, but they are parallel. Okay? So this one would be parallel. All right. A landscaper plans to install 2 new paths in a park. The new fountain path will be perpendicular to the east path and lead to the fountain. The new picnic path will be parallel to the fountain path and pass through the picnic area. What are the equations in point slope form that represent the new paths? Oh my goodness. Point slope form. So we want one that is let's see, so we're talking I'm gonna move this up so I've got room to write. But I'm gonna lose the words off the screen. The new fountain path will be perpendicular to the east path and connect the fountain. Okay, so we're gonna get here where we can see the pictures. You're gonna have to help me with the words because they're on your paper. So, so I want perpendicular to this slope that goes through this point. So what do I need to do first?
Up one, right, four.
Can I find that slope?
Up one, right, four.
Up one, right? 1, 2, 3, 4, 5, I think, isn't it?
Yep.
So the slope of the east path is 1/5. So what's my opposite reciprocal slope?
-5.
-5. So I'm gonna write using slope of -5, and what ordered pair am I gonna use?
1
15 comma 2.
15, comma 2. Okay, 15, comma 2 is my ordered pair. So we want to write, was it point slope form?
Yep.
Point slope, y minus 2 equals -5 times x minus 15. Okay, so that is the first one. And the second one, what's the picnic area one?
That's parallel
Parallel to the east path,
to the fountain path and pass through.
parallel to the fountain path
And pass through the picnic area.
that passes through the picnic area. So we want the same slope as this, since it's parallel to the fountain path, and it passes through this point. So we still want a slope of -5, whoops, slope is -5, and what's my ordered pair now?
5 comma 6.
5, comma 6. So y minus 6 equals -5 times x minus 5. Does that work? That wasn't too bad.
Nope.
I mean, you have to kind of think through one thing at a time. This is the one you didn't have on your page because I ran out of room to print, so I didn't want to put one more on your page there. The equation y equals 2x plus 7 represents the north path on a map. So we're back to that picture, okay? Find the equation, so you guys can see it on your page. I can't see both things at once. The equation y equals 2x plus 7. I'm gonna get rid of this. And I'm gonna do this, okay, 2x plus 7. So y equals 2x plus 7. And the north path on a map, find the equation for a path that passes through the point 6, 3 and is parallel to the north path. So 6, comma 3. What? 6, 3, and is parallel to the north path. So it's parallel to this, right? So M is 2, and the ordered pair is 6, comma 3. Is that it? So what's my equation?
Y minus
3 equals 2 times x minus 6.
Okay. And then the last one says, find the equation for a path that passes through the same point but is perpendicular to north path. So through this point, but is perpendicular to this. So what's perpendicular to that?
Negative 1
negative 1
half.
over 2.
-1/2, but still goes through the same point, which is 6, comma 3. So give me the equation.
Y minus
Y minus 3 equals -1 half times 6 x minus 6. You guys got it.
All right.
Yeah, that's not what I said.
That's not what you said?
No, I'm just saying.
Oh,
Colton said nothing. Yeah.
Okay, guys, that's it. Parallel and perpendicular lines. Most of it's gonna be point slope. They might have you change the equation after you get it into point slope. But that's it. I will push out the assignment to you as soon as I get the recording